Well, welcome to our structural modeling middle of the month, August 18th discussion. And today we're going to talk a little bit more in general about the Model-Based Engineering Manifesto and the how that relates to structural modeling. That was a topic that was suggested by Kevin. So, and I think it's a very interesting topic. And what I will do is just kind of outline briefly why I think it's an interesting topic. And the model-based engineering, just in general, seems to me to be focused on producing solutions to problems. And structural modeling is focused on defining the problems that need a solution. And there's usually two completely different groups of people involved, especially in large, complex problems that need to be analyzed. And these different groups of people have different capabilities in modeling and different ways of viewing the world. So one of the more interesting things that I found when I was reading a little bit about Capella that comes out of the European Union was in 2005, what they found is the people they were working with in their large organizations really struggled with the ideas of object orientation and ways to put things together. So they focused more on the older style functional flows and sequential type of analysis techniques. And then what that did is it triggered my memory for some work that was also done and presented at the CSER, the Conference on Systems Engineering Research in 2005, for people that were working on the software-defined radios and other types of analysis across a very wide group of people, ran into the same type of conceptual barriers in different groups of people. So I thought that this was interesting and something that could be talked about. Good morning, Janet.
Good morning.
We're just getting kind of outlined here. I kind of gave my point of view, what I thought would be interesting to discuss about structural modeling and model-based engineering. So anyone else can feel free to chip in.
Is Kevin going to join us?
I suppose so. I haven't heard from him. He had planned on doing that.
Right, I thought he was, yeah.
But he's going to go ahead and kind of fill in a little bit and see if he gets here. And of course, Kevin's work and the work that they do in Cyprus is all large-scale social systems. And what they are focused directly on determining the structure of problems in large-scale social systems, and modeling that, and not necessarily designing a solution. But what they're doing is they're trying to determine the shape and form of the social problem they're looking at. So that's that, and they use graphical modeling, language modeling, and so forth. So that's why I believe structural modeling would be a really good front end to the process of designing the model-based engineering, where we're designing solutions. And I noticed that there are some interfaces and some interactions.
Right. I think of the structural modeling as being unconstrained. It's socio-technical systems, which is why it's so useful, because it is not, it's not constrained to one or the other. It's about how everything interacts with everything else. And you need to get a handle on that in a big picture view before you can zoom in. So I was hoping to get Kevin's take on that. I think the biggest problem that model-based, model-driven, model-oriented, ontological, semantic efforts always face is crossing disciplinary boundaries. That you can do a pretty good job within one defined domain, but when you have to deal with messy problems that span these domains or that are undefined across the boundaries, then the protocols and the schemes that you come up with for each of the disciplines don't map well from one to another. So I think that's where Warfield was such a pioneer in saying, let's step back and look at how everything is interacting in the problematic situation, whether it's, wherever the constraints come from. Take a generic view of the problematic situation. Anyway, so go ahead with your. Are you going to videotape this or?
Oh yeah, no, it's the broadcast. We are broadcasting. It is being recorded.
Oh, okay, good.
And it's well, I guess to me, one of the things that became kind of an insight to me when they talked about the application of interpretive structural modeling in Mexico, and when they put it into the presidential suite, where that was part of their government management techniques, and they were dealing with large groups of indigenous people, and then you had the dominant Mexican ruling culture, and this dominant culture had language, concepts, tools, and so forth, but that were really not well known to the indigenous people. And because there were three forms of language, prose, structured graphics, and mathematics, and those being isomorphic, what they found they were able to do was they were able to, instead of having very long, involved workshops like you do when you're all from one culture, they would have short workshops with the graphics and the prose, and then they would have like a learning and almost individual language normalization. And so because of the pictures and the structured graphics, the indigenous people were able to understand and communicate enough with the dominant culture that they were able to make real progress. So I think the other part of Warfield's technique is basically the model exchange piece. And he did the model exchange between mathematics and structured graphics. Mary and I added the prose section to it. So that I think that really helps. And when they were talking about the tribes and people trying to figure things out, then I went back to work, and I've got the electrical engineers, the aero engineers, I got the mechanical engineers, I got the software engineers, I got the schedulers, I got all these guys, right? And they don't talk to each other. And I said, tribes. these guys, basically just have their own language and their own parts, and really need to have something to help integrate that.
Isn't that the whole point of an ontology?
Well, that's really a good question, actually. And an ontology is really good to, I believe, and what it's supposed to do is name things that exist, right? And as I talked about earlier, I just got the Semantic Information Modeling of Formalized Languages book for JELIS, looking at it. And there was some discussion on the ontology list about JELIS and the ontology that it's based on. And one of the things that it was commented on was that everything in JELIS is a concept. There's no like real concrete things, right? But that's natural because it was written by software engineers and it was written by information modelers, right? And so, how do you actually address and work with a complete ontology, right? I think is the question.
Is it a misnomer to assume that there is a singular ontology? I'm translating a complete ontology into a single ontology. In most complicated environments, engineering environments that are based on, they're ontologically based, you often have many ontologies. You'll have, as you described, an ontology for each engineering domain, perhaps an ontology even separate to a product line or product type. And the point is to be able to develop bridges between one domain and another domain so that the two domains can talk to each other. And that's the whole point of an ontology, is to be able to create that communication bridge.
Right. Well, what Joe is just referring to there, the ontology forum, grew out of, as I understand it, the OMG effort, W3C effort to find a standard upper ontology, we've been, Joe and Mary and Michael and I have been following it for decades, and it's, all of these are still very hotly contested issues. Is it possible to have a top-level ontology? Is it possible to have, a single upper ontology? Should one instead have federations of micro theories? So this is not well established, and of course, one could set the objective of just bridging between ontologies within one engineering enterprise. But Michael worked at JPL, and he was working on this in the 80s. And what you were talking about, going back to the old days of the corporate memory, the somebody who understood where everything was, and how do you get that into some digitized form? But you're still dealing with social dimensions, social cultural dimensions with the people in the system. Mm-hmm. So the engineering is not just the artifacts. The engineering is also the development process and the management and the stakeholders and the sponsors and the users and all of their ontologies, if you will. So even if one set a goal like maybe Jellish has of saying, let's just figure out a common language for engineering, what are the boundaries of that? Where do you, that's not going to be one world ontology. It might be one engineering ontology. So yeah, issues that people have been debating for quite a while. Interesting issues. And I'm curious, in your in the conversation, how was this discussed there? What were the impediments that were identified to identifying one ontology, or did you?
Well, we are not advocating one ontology. We are advocating semantically defining your ontology, parentheses S around that. In my own experience, I find that the federated ontology landscape is more productive than trying to have a single overarching encompassing ontology. And I can give some anecdotal evidence for that direction, but the point of the conversation around that was that without something like an ontology to help define the communication boundaries between the and or define the and systematize the communication, A, you can't communicate to a computer, and B, you can't effectively communicate within your domain if without something like that, because everybody tends to do their own thing. So where we come from is a lot of modeling efforts tend to be isolated, single person, single group. Over here on this product, particularly in a environment like I am, where we do all custom systems, and then the group over here is doing their own model, and there's no communication between the two of them. But if they both are using the same ontology, they could communicate if they so desired. And that's where we're trying to get to, because in in the manifesto, the Holy Grail is a integrated and federated integrated modeling environment and capability.
Mm-hmm. Right. I think everybody that I interact with would agree with that Holy Grail. And it would be, as I said last time, it would be nice if that was recognized as a national priority or something as a grand challenge, so that everybody would know at least that we're all trying to work toward that. Then you step back and the next question is, how do you get there? So
I'm not sure how you define something as a national grand challenge,
right.
But there is some fair amount of traction even in that direction. The Department of Defense has in the Office of Secretary of Defense, defense, what's the A stand for? Acquisition?
Mm-hmm. Right.
Kristen Baldwin and Bill Zimmerman's group have a pretty significant initiative that they're driving down to the services to define a digital engineering capability, cross-pollinating digital engineering capability, and the services are taking that very seriously. Right. I know the Navy is trying to build a Navy-wide ontology. I'm not sure where they are with that or how successful they're being with that, but I know there's effort going on in that regard, and they're certainly driving hard on several initiatives toward the digital engineering capability. Air Force has its own programs, and they're doing similar things, just different directions.
I think one could have something like a moonshot or something like that would help.
And maybe it should be socially driven to help the country communicate.
Right, that's right.
Just saying.
It's interesting to me that a lot of people talk about ontologies, but I don't hear as much mention or talk about as taxonomy. And I'm wondering, is an ontology really worthwhile or actually useful without a taxonomy?
So in software engineering and in systems engineering, the taxonomy is embedded within the ontology. The ontology is an evolution beyond the taxonomy. So the taxonomy is the data dictionary, if you will, and the ontology is how you're going to use that dictionary to communicate.
I think, yeah. So these are some of the things I think it might be just very interesting and maybe productive. I think I might do this for the next September 1st conference, is go through and start outlining and defining some of these terms and looking at them and then talking about them and then giving some examples of expressiveness. So, because when I was reading through and going in a little more detail here, I just had some questions, and I thought I would probably go through. Thought it might help just to write up some observations and to see if there's consensus on how these terms are being used.
Yeah, Joe did were you the one that somebody said used to work at JPL?
No, Michael. That
Michael
is,
used to work at JPL. So Steve Jenkins at JPL is doing a considerable amount of current work in the area of model-based systems engineering laid over in ontology foundation. So I think he could come up with some pretty interesting examples of how that's being done.
good.
There's also an effort at the Department of Defense to define a system engineering taxonomy. That's out of the OSD DASD/SE group, if you like acronyms.
Yeah, that's interesting. I don't know if they can share what they're doing and their ideas, but it might be good to take a look at that.
He has been sharing it extensively, or Steve has been sharing it extensively, so I know it's publicly published. I believe the taxonomy is unclassified and can be published, or is published. I'm not sure. Frank Salvatore is the one doing that.
You said OSD acronym?
OSD, Office of Secretary of Defense. DASD, I think it's Defense Acquisition.
Right.
Oh, shoot, I can't remember what DASD stands for, but it's
And
and then SE, System Engineering.
And then the person who is doing that, you said?
The person who's doing the taxonomy is Frank Salvatore. He's actually on the list here.
Okay, I see. Right.
He's Agility is his company. He's a consultant to
I see. Right.
DASD.
Okay. Yeah.
But he's involved in COSI, in the digital artifacts and digital engineering working groups.
Right.
You can easily find him through those. I think he's the working group lead or something.
Well, that's good to know. I think again, I just wanted to also figure out if there's a fundamental difference between the way people actually view models. And as I said, there's been some anecdotal evidence that was presented at the CSER 2005, and also anecdotal evidence from around the same time frame that came out of the European work there that brought their model-based systems engineering approach. The most interesting part, too, is that there's an interface between some of the models and SML, SysML. So that would be good to see which ones of those are transferable and which ones are not. And then my main interest there is to look at those and see how those transfer to the graphical representations from structural modeling that have been used for decades. So there's a smaller subset of graphics that are used in structural modeling. So it would just be interesting to see how that is naturally developed and what people use and what they discard.
Is structural modeling based on structure analysis?
Structural modeling is based on logic. It's based on just what's called a triggering question. If you have a very large group of people and you go through and do some work and kind of figure out who are the players in this problematic situation, then you develop a triggering question which has a logic statement to it, and then you go through and work different information gathering activities to order things. So if you have this is more valuable than that, this is more important, that develops a linear structure. You can develop connected to, this particular problem is connected to that problem, and generate a network, things like that. So it's very high level front end. Let's go and explore using conversations with people, groups of people. Sometimes you can use, electronic document interaction.
That would be an interesting tool to use against the manifesto, because these thoughts here all interact and interrelate to each other in a variety of different ways. If you talk about, for example, information over artifacts, we're dealing with describing information in a certain way. We want to be flexible in that description of that information, but we want to have expressive rigor, which implies an ontology or a semantic basis for that that expressiveness and that information. We want information, not artifacts, meaning we want all the things that make up a particular information body or blob, if you will. The not just the descriptive part of it, the behavioral part of it, the linkage and tracing part of it, all that is part of that information, which is where that goes. So you can make lots of different lines and connections between the various parts of this this manifesto. It would be an interesting exercise.
Right. Well, and in large scale, very, very large scale systems applications, there's some examples of the effective application of structural modeling to that. This is the redesign of the defense acquisition system in the United States. So they did that basically, and it was between the executive branch, of course, the legislative branch, and they worked with the Pentagon. And so the whole redesign process, all the people involved in there, that was one example of an application of structural modeling. There's been a number of other applications where people have used structural modeling in very large scale systems.
So can I see that map? I need to get some funding on a certain project. Just kidding.
Oh, right. Well, the good part about the DoD acquisition redesign was one fellow got his PhD out of the City University, I think, in London on it. So all of the work and everything is published in his dissertation, and there's a number of follow-ups. This information is all available. I can send it out as some pointers, information and notes for the meeting afterwards, if anybody's interested.
That would be interesting. Yeah, I'd be interested in seeing that. So Michael never came on, huh?
Michael?
We have Peter and Hugh.
Michael usually shares a computer with Janet. Mary and I are in two different parts of the house, so we don't get feedback. Right?
Yeah, we stay in the same room, so we just use one computer.
They like to sit close to each other, so they use one computer. Mary won't let me sit close to her anymore.
Here's a voice to prove that I'm here.
Yeah, I hope Kevin's okay.
A disembodied voice.
Well, it's recorded.
One interesting critical point on the focus on digital models is that again is privileging the artifacts over the informing. It's like a premature design constraint that people tend to think as long as we make it digital, then something magical, rather than thinking about the leaving that to maybe that will emerge likely at some point, but leading with it bothers me in the digital twin kind of discussion. Instead of, I think it would be better if they talked about modeling, if they talked about model twin instead of digital twin, because the latter is imposing a particular design. And as Joe has been talking about, the models are isomorphic between mathematics, structured graphs, and logical propositions. So that freedom should be retained up front.
I don't conceptually disagree with you, but The difficulty if it's not digital is that we don't have a way to connect different types of media in a design environment. I can't integrate my Mylar drawings into my paper documents unless they're both digital. So it's providing a unifying media.
Right. Well, one of the pioneers in this ontology work, John Soa, who is very active on the Ontolog forum, one thing he brings is a perspective from the 70s from IBM, and how just because you digitize something doesn't mean that it's going to be accessible, or you know, yeah, right. Or but there have been many efforts to define standards, and just because it's digital, it can be sitting somewhere and inaccessible, forgotten. It's really the standardization that gives you the power. It's the combination of the digital media and the standardization. Yeah.
Right. And I think that's why I like the federated semantic environment rather than a single overlying and attempt to define an ontology for everything. It's the bigger you get, the more difficult it is to make that standardization really work in a self-contained place or organization or project or something. I can have enough control that I can then say, this is the ontology for this. And then if you have an ontology for that, I can map the two together and maybe we can communicate.
I think that there's another implication when you're talking about digital format. And that's really, I think what you're implying is formalized. Because really, if you're going to get it into a digital computer, it's going to have to somewhere be executed on the basis of first order logic. So essentially, the implication of digitization is, yes, but it is a formal type of representation. It's not informal. And so yes, human beings, when we're starting to define problems up front, we're dealing with informal language for our first concepts and requirements. And so what we're really trying to do with the systems engineering and the structural modeling project is drive the formalization of the prose. Okay, what specific parts of natural language can we formalize easily? People can easily pick up, that they understand. I don't try to force them to think in a way that they don't naturally think. And just looking at the two different modeling branches, I think there's sufficient evidence to show that that's the case, that there are people that actually view the world differently. And so we need to have, first of all, tests, which you can kind of quickly test a person and see, oh, how do they think about these things? And then present the information to them in a formal way that they understand, and don't overload them. The primary thing I find about most digitized and computer-based systems is we tend to not to ignore the fact that people have constraints in what they can actually think about. And so we just totally overload folks and they get lost. And a lot of the times I would see that happening, and people would say, well, we just need to get smarter people. We got to find the smart guy that understands it. And, I finally started telling people, I said, look, you got the smartest people you're going to get. You
got what you got.
What you have to do is you have to actually get this problem broken down into a way and presented in a way that people can understand it. Because in most of those cases, they had some very, very, very bright people, and they were just overloaded.
Well, I think we talked last time about how a semantic ontology is a limiting communication paradigm. And I think that's part of the whole point, is to limit the things that can be communicated to this set of things, so that we at least know what this set of things are. If it's a sufficient set, then you can sufficiently communicate what you need to do the concepts you need to deal with within whatever it is you're defining, whether it be a social or an engineering system.
Yeah, I agree. And but also I think in the front end piece where things are still quite informal and you're trying to formalize some of these parts so that you can take advantage of the benefits of formalization like digital encoding, integration, and so forth. But you also need to have some aspects of learning, group learning, so that people can actually learn from each other about what they actually mean, what are their semantics in the group. And that was one of the things about the interpretive structural modeling process is actually it had a physical space was defined as part of the process where people would come together. It's called the observatorium, where people actually come together and work together to understand each other and to then try to start outlining the problem in a more formal way. And so there's the idea that yes, this digitization and formalization is very good, but it's only as good as the quality of the information that goes into it. I can make wonderful models that are absolutely wrong, and I can exchange them with everybody, and I can send them everywhere, but they're useless, right? So up front, what we need to do, I believe anyway, is in this structural modeling, interpretive structural modeling area, is understand the limitations of people, understand we have people that think differently, and so we start going from this natural language, informal transition to a more formal representation is really important, and I don't think it's given enough consideration at all, personally.
We would, without saying, well, we did all that and thought about that. We did have some thoughts in that regard on the manifesto. If you look at the third principle down, an essential and dynamically changing property of model information is its credibility to those people and processes which will consume that information. So we're trying to take into consideration that whatever it is you think you're modeling, it has to be most relevant to the people who are going to consume that model, right? And then over on the second column, the fifth principle, we seek an extended team across engineering disciplines with common and integrated understanding of the identity and nature of the model information as well as its content. So we're trying to grasp that whole notion you're talking about of that your communication base, the model you're building, the audience you're building it for, has to be understandable, or you failed. Your model is useless, as you say.
Well, that's kind of, yeah, that's a very important point. But one of the things that's really kind of, again, interesting is we have two types of interpreters going on in this case. One, we have a digital mechanical type of interpreter, and then we have a natural human interpreter.
Right.
And so the digital mechanical interpreter, all the semantics are generated there using syntax rules, lookup tables, all that kind of stuff. It's all logically built. All of the semantics for the human being is in context. All communication and all semantics is based on shared context among the individuals involved. And we spend no time trying to develop the shared context among the human beings so that they can understand each other. And so that again is one of the reasons and one of the roles for the observatory is to basically get people together, give them time so that they can start understanding each other and developing a shared context.
We would agree with that. The notion that just because we're all Americans and speak English or whatever the situation is a gross presumption. I developed software systems with international teams, and I can tell you that for firsthand experience, that communication as a afterthought fails.
Yes, well, I've had some experience with people that really, and still today work with international teams that produce technical products, and it's even the culture.
Right.
You know, the culture of how you get things done, and it's really, really important. So, but
Here's a good example for you anecdotally. We had a system that was geo-based, going to be based on zip codes, and part of the engineering team was in India. And as it turns out, Indians, or the Indian, I don't know, stereotypes them, but they don't use zip codes in the area that the team lived. So they didn't know what a zip code was. It's pretty hard to program that if you don't know what it is.
Yeah, and it's like addresses in Japan, right? The addresses in Japan are completely different than, conceptually completely different than they are in the United States. So yeah, there's all kinds of issues like that. But the point I'm trying to make is that this digitization, the semantics, all is very important. But the quality of the information that goes into the mechanical pieces is dependent upon the understanding of the human being, group of human beings that actually put that together. And the human beings have constraints. They have conceptual constraints. They have language constraints. They have cultural constraints. And time and time again, people were never given enough time, in my experience, to actually develop a common understanding. And so what you did was you had to go through and do the best you can now, fail at that, and then go back and fix it. And that's how we developed our common understanding, is fixing failures. That was our common interaction.
Trial by error is a tried and true engineering method.
Yeah. Right. And in developing ontologies, there's a tendency to, because one is not aware of one's own culture, one says, okay, there's a thing called a zip code, and there's a, and that is presumed to be a thing in the world, whereas it's not a thing in the world for most of, for a lot of the world. So it's pinning down what the actual things are is problematic and much more context sensitive and culture specific and variable. I was thinking about you have in the invariance there. I like the second principle about we seek to discover the essential information we seek to discover and produce is invariant because of the very nature of engineering. That's a nice way of phrasing it. What are the invariants? A zip code is not an invariant, but the ability.
An address might be.
Or the need to locate somebody, right?
They will be embodied within your semantic definition, which is.
But that's just shifting the from ontology to the semantics, the need to locate there are invariants. There should be invariants in human experiences, even no matter what the culture, and maybe we could say, or for 80% of the activities that we want to address, or something like that. Maybe it doesn't have to be 100%.
If there weren't, then we would not be able to define an ontology that would be worthwhile, because it would not last. It would be constantly changing, constantly dynamic, or constantly in motion, right?
Right. Well, that might be what the result is. And we might end up realizing that the sort of the mishmash of concepts and terms that we use and have been using for hundreds of years, and the way languages evolve, that might be unavoidable. Because language sort of, there's an interesting linguist wrote a book called The Descent of Language, I think it was, or about evolution of language. Deutscher?
Guy Deutscher.
Guy Deutscher. And he talks about how language is, you should think of language as a living system, that it doesn't stay put. You can go back to Roman texts where people were bemoaning the fact that the young people were making up words and misusing the language and, you know, innovating. There's a constant tendency to innovate. You find it in all of the languages of the world. So it's if that's the context that we're working in, if we accept that, that legislating language will fail, then how do we find a middle ground to get the invariance that we want, but allow the flexibility that will keep it from breaking, you know, so that it will be robust and maybe evolve in a robust way rather than being brittle.
Yeah, isn't it just a factor of time or dynamics? The amount of change has to be less than your ability to control the change or adapt to it.
Right.
Well,
Yes.
Right. More degrees of freedom, and then you have to be able to control the degrees of freedom that you have. So if the rate of change is faster than you can adapt to, like or your signal is so fast that you can't acquire it, then you have problems for sure. That degree of freedom goes away. But I think this just as a practical, just to spin this back to a very practical type of observation and to talk about something I'm working on now. And that's, we've worked up the AMEI, we've done quite a few logical applications. Both work very well in a standard SQL database. First order logic is very, very nice in relational databases. But relational databases are constrained for a number of reasons, especially with natural language and natural language understanding. So I've been looking at things like Apache Lucerne and Elasticsearch that goes through, essentially now putting a lot of documentation together and starting with actually the publications that Mary and I have developed and the references in that. But when you go to these linear type of search techniques that are optimized for natural language, you lose some of the capabilities of first order logic. And so what I'm thinking about, in fact, what I'm thinking about developing is a layered system. And so the layered system, one with Elasticsearch, and you have a distributed type of cluster that's doing all of these natural language analysis techniques, and have those feeding into other types of first order logic types of analysis, databases, spreadsheets, and so forth. And I think that maps at the database and the spreadsheet level. I think that maps very well to some of the concepts I see in Jellish. And so I'm thinking that those changing things will always have the dynamic language, and you have to get it in context. And so that going from an Elasticsearch natural language type of search base, that you don't just talk about, or you don't just keep track of the subject matter, you know, the words that you're doing there, you keep track of the context. Track the documents, when you did it, what's your version of this particular context that you're in. And then those can be fed up into databases, relational databases. And I think that'll work a lot better for what we're trying to do. And I think it relates to the idea of a changing language, right? Because when you're just starting out and you're just starting to search text, and you don't really know what you're going to run into, you start just, it's like the way I like to go to a library, right? And that's one of the reasons I kind of hate physical bookstores have now kind of going away, right? I used to go to a bookstore and I had a general idea of what I wanted to read about or study. I go in there and I'd start, just looking at the book. So how are these things categorized? What's near this? What's kind of like this, right? And That's really
Sure.
important.
Is that because the human eye can scan those bookshelves better than the you can represent on a computer screen now, so you don't get the same depth and richness of search results from a computer search screen? I like libraries too.
Yeah, well, let's just talk about a bookstore for a minute. I think, first of all, like, there's some real advantages of the bookstore because someone has selected the book for it to be there, right?
Right.
So, like, if I go to the University Bookstore or Barnes and Noble, like, if I want to look for new technical books that are really hot and selling, I can go to the University of Washington Bookstore and they'll have it, right? They will have that book because it's selling. People are interested. It kind of tells you what's going on. To me, that's better than, all the little feedbacks on Amazon and all that stuff. And if there's nothing in the area that I'm interested in, that also tells me something else, right? It kind of tells me, well, maybe I should not look in the popular area, the stuff that's happening right now. Maybe I should go back and look in some of the more research types of things, like in the libraries and so forth. So, that just those types of things. All context information. Everything I said there was about the context. It wasn't about what was in the book. It's like, oh, how do I make a value system about the context? You got to keep track of that context.
Right.
So we have a new person with us today. Would you like to speak and tell us who you are? Or?
Yeah, hi. My name's Hugh Bazzi. I actually started to try getting engaged in this when I attended the INCOSE International Symposium back last month in Washington. Can you guys hear me?
Yes, we can hear you, Hugh.
Yeah, so I work with Mentor Graphics, a Siemens business.
Uh-huh.
And I'm a systems engineer. I'm actually in technical sales. And I support systems tools. I work with a tool from Mentor called Capital Systems.
Oh, okay.
I'm very interested in structural modeling and understanding how that fits in engineering process. And what the main thing is how it fits, how it's used, and what's missing. What would be, because I keep hearing about. How SysML you capture. I'm not a SysML user or tool user. I'm not very familiar with the SysML modeling, but I know somehow the structure and what it involves and what it contains. So I'm basically what I can do with the tool set I have is I can consume some of the structural modeling and parameters, and I'm just trying to understand the flow so I can make it a better fit for my customers.
Okay.
I have better proposals for my customers when they do that.
So Hugh, as a EDA engineer, how does the manifesto strike you? Do you relate to it at all? I haven't touched the EDA community yet, so I'm curious to know whether any of this resonates to the community.
Well, it does. I think the main thing is understanding the for SysML modeling and modeler who any engineers who have been capturing their models. You mentioned something that you need to know your the model users, who's going to consume that model, and you need to target that. That's very important in my opinion. And what engineers have been doing and systems groups have been doing in research, they're just following standards and trying to capture everything, and then they fail in making that model attractive, basically, to the downstream, to the detailed design teams, to the implementation. And for example, one of my customers, it's a big OEM here in Detroit, and they spent so much time on modeling in SysML, and then they fail to make the program teams use their models and adopt them. It's too complicated. It doesn't serve the purpose. It does not. There's no connection with the other world of implementation, if you want to call it, or the detailed design side.
Right. One of the concepts and topics that we spent a lot of time talking about in the conversations that led up to the manifesto was the notion of the minimal model. So build the model, to define a model that is minimal to what you need, what you're trying to build, whatever it is you're building, and then within that concept, you can expand that minimal model then into what we call patterns, so that now you can build minute patterns that you can then use for a variety of reasons to help constrain that minimal model. And that was the whole point of it, of that conversation, was just what you're talking about there, is we all experience the model that evolves well beyond the needs of the system that you're trying to build and takes on a life of its own. And for that dies of its own weight. Those ideas are encapsulated into things like common and integrated understanding, the credibility of to those people that are going to consume the information. You lose that credibility when you have a model that's too complex, too cumbersome to grasp. The idea that the intended use of a model information sets a higher bar for required investment in model verification, validation, and certainty qualification. Those are the same concepts involved in that. When it gets too big, too involved, too massive, then you can't verify, you can't validate, you lose your credibility. Right. Those kind of things. So I'm glad you come across some of the same thoughts that we had.
Yeah. So what we have been doing is we actually at Mentor with the tool I'm working. We happen to be first we started with implementation tools or detailed design tools for EDS, electrical design systems, or wire harness design. So you're talking about wire harness design, like it's on the physical side, right? And then we had another tool for network design and other tools for in-vehicle software design. So we took all that and it eventually became part of a complete suite, Capital. We call it Capital. And then 5 years ago, we came up with a tool called Capital Systems to feed our tools. First of all, are support generative design, and we have a lot of automation and intelligence in our tool that supports that generative design. So we thought, why don't we go back one level of abstraction and get into start with implemented functions and go forward and feed those domains. So that's what we came up with. The Capital Systems, we capture functional designs, designs, a set of designs that contain functional implemented functions, and you can relate that to something in a structural model in a complete SysML model, for example, like internal block diagrams, right? That can feed your design. And then what we have is we have those functional designs, and then we also have the topology of our product. For example, if you're working on a vehicle, you would capture the components where you think they will fit in your product, and then you would start allocating those functions to where they need to go on the components. If you guys would like to see what I'm talking about, maybe give me what your feedback is. That would be great. Or maybe next time we can do that if you don't have time.
Well, Hugh, that's really good to know. It's very interesting that your company's thinking about dealing with these higher levels of abstraction. Normally for our video conferences, we try to stick very, very close to 1 hour, which is up now.
Yep.
And so we have, we'll be signing off here in just a few minutes. Hi, Jack. We're done now.
Hi there.
So the next video conference will be September, let's see, 1st, I believe.
Yes,
Yeah,
September 1st.
September 1st, and I think what we'll do is we'll prepare a bit of a document that kind of outlines these concepts, things people have talked about. Also, give 1 or 2 examples of what's going on, and some maybe some things to talk about. Try to get that out as a read ahead, about a week ahead of time. Appreciate everybody's participation, and we'll see you in a couple of weeks.
Thank you.
Yep.
Thank you. Bye-bye.
Before we sign off, Jack, you and I met 2 years ago. I wanted to add to